It's perfect. Is it? Mm-hmm. You have a question? Yeah. A lot of people went to the IBM conference.
Yeah, maybe we will go, I don't know, if someone wants to go, we are allowed.
Yeah.
9 o'clock till 10.
Where does it take place? Here or elsewhere? Uh-huh. Well, I hope it's going to be interesting. Anything else? Well, thanks for making me aware of that.
I have a question.
Yeah.
Is it really bad to call receive with argument 1? I mean, receive only 1.
It still works.
Yeah, it works.
It may not be the most effective way to get things done. Usually the advised offer size is some power of 2. And 2 to the power 0 is 1. So I guess it's not against the rules. Whenever you deal with such questions, it is always a good idea to make decisions based on metrics. There are functions that allow you to measure exactly how long it took to execute one part of code or another. So you can run one test and then another test, then compare them side by side, and then make a decision without relying on intuition, emotional guidance, or the stars. There's always something you can count, something you can measure in order to make an informed decision. So last time, if you paid attention, you learned how to do some basic operations with a client and a socket. You played with sending different commands, and if you implemented the assignment, then at some point you ended up inventing your own protocol, and you call it your program. Today's assignment is to think about implementing somebody else's protocol, and namely HTTP. It stands for Hypertext Protocol, Hypertext Transfer Protocol. It is a protocol web browsers use to talk to a web server and retrieve content such as pages, photographs, comments on Facebook, and so on. So most of these things are happening through the use of HTTP. It is a very interesting protocol. It is widespread, and it is easy to understand. It is defined in a document called RFC 26, I think it's 16. But if it's not this one, then it's 2660. And if it's not in that one, then you just look it up on the internet, HTTP RFC. As you can see, it's a long document with a lot of text. You don't necessarily have to read the whole thing, but you need to learn how to read an RFC and how to find the information you're looking at, the information you're looking for. I will share a few basic things about this protocol. So you have a client and you have a server. A server such as Apache or Microsoft's IIS or Nginx, or there is one called YOS, which stands for Yet Another Web Server. Very interesting name. All of these servers are typically listening for incoming connections at port 80 using TCP at the transport layer. There is nothing in the universe that prevents you from binding your server to another port number, let's say 1984. However, it is expected that whenever a client connects, according to the rules defined in this document, wow, you have another one? Thank you. So, wow. According to the rules defined in this RFC, a web server should be listening at port 80. That's why whenever you type some web address in your browser's address tab, you don't have to explicitly indicate the port number. You just give it the address, and it knows that by default it should connect there. So it establishes a connection, and this protocol is designed in such a way that the client is the first one who opens the dialog. So once the server has accepted your connection request, you are the one who has to send a request. And HTTP gets things done using the series of methods, such as get, post, put, head, delete, options, and all of these keywords are defined in the RFC. So I'm not making things up. There's always a place where you can look it up. You have to send a request. The server takes the request, analyzes it, and sends you back a response. In the first versions of HTTP, as soon as this response is sent, the connection is closed. So it's broken. And if you want to download something else, you have to send another request, get another response, and so on. So let's analyze the shape of one request. So the syntax is as follows. You have to give it the method name. These things are called methods. You have to give it a method name, a URI, which stands for Uniform Resource Identifier, which is another thing defined in another RFC. So there usually is an RFC for anything. So you give it the name of the method, the URI to which this method applies. Then you can add additional data to your request. And then you have to place an end of request marker, which in the case of this protocol is \r \n, \r \n. So you repeat this twice, and whenever the server receives your request, it keeps reading until it reaches this point, and then it knows this is the end. In some cases, you may also have a request body. So this is a header. It is separated from the request body using this sequence, and then the body can be some data. It could be the code of an HTML page, it could be a JPEG photograph of a smiling cat, or some binary zip file that you're downloading. The response has pretty much the same structure. It has a response header, followed by the same separator sequence. It is also represented as CRLF, carriage return line feed, and it's, of course, repeated twice, followed by the response body, which is some data. So that's very simple. If you zoom into the request header, you will see a bunch of attributes here. Could somebody perhaps share a few names of attributes you've seen in HTTP requests? Well, no answers yet, but that's because this is your first exposure. So these request attributes are used to tell the server more details about what you want. For example, one of them is accept language. So the request attribute is accept language, and you write that here. Then you write a colon sign, followed by a string, which is the value of this attribute. And with this one, you can indicate which language you want the web page to be served in. For example, if I only speak Russian, I could write something like this, ru. And the web server, if it has a Russian version of the page, it will try and give it to me. If it doesn't, then it will just give me whatever it has. You can also use a special syntax to indicate more languages. For example, if I speak Russian and Romanian, then I could indicate more languages. Not necessarily with this exact syntax where you have them comma separated. You can also indicate a so-called quantifier or language preference that says something like this. This is the coefficient of preference for this language, followed by some other coefficient of preference for another language, and so on. So if the server has the same page in multiple languages, it can choose the one that you will like the most. If it doesn't have this one, then it will go for that one, and so on. There are also other things, such as I don't remember the exact name of that attribute. I think it's accept type or content type, where you can indicate whether you can receive responses that are compressed. So instead of sending you the actual data, the web server can compress it first, send it to you, and then you decompress it and you get the same thing. This way you get to save a few bytes because the data are compressed. Another interesting header attribute is called user agent. This is how the browser identifies itself to the web server. For example, in this header attribute, I could write something like, I am Opera 9.8 running on Linux Mint. So the web server receives this request. If it wants to, it could take this information and put it in some database such that at the end of the month, you could look at some nice shiny statistics saying what are the most used browsers by your readers, of your website, and so on. The response has a bunch of headers as well. One of them is content type, which indicates what kind of data you are about to receive. It could be something like application/XML, meaning that in this body there will be an XML file. It could be application/JSON, same thing but JSON. It could be plain text. It could be a PNG, etc. So there are many types of content that you could fill into this attribute. What are your questions so far? Well, if there are no questions, then I help you. What is the method head designed for? Okay, so the answer suggested by your colleague is to receive just this part of the response without getting the whole thing. How do you know that? How do you know that this is what head does? Maybe you're trying to lie to all of us. You're making things up.
No, I've used it to, for example, to find out if the server has certain files on it without getting the body of the file.
Mm-hmm.
That's an example usage of head.
Okay, but were you born with this knowledge? or how did you find out that this is what it does?
I had tasks sometime in my high school when
Mhm.
I did that. And my job is web development,
So is this information passed from generation to generation? Do you have to hear a story from a shaman to learn what head does?
Well, that's what I read in the RC.
Yeah, that's what I was hoping to hear. So at some point, you're out of your intuition suggestions. So for example, if I ask what does delete do, you might apply some common sense and say it deletes a resource. And that would be a correct answer. What do the other ones do? If you don't know, you can ask someone. If you still don't know, you can do some observations. For example, you can set up a web server like this one on your machine. You can write a client that sends, let's say, an options request. You get a response and then see what else happens on the server. Perhaps you can read the logs, or you can look in the source code of the server and figure out what happens. But as a last resort, you read the manual. And this is the manual that you can refer to. And there is another interesting thing you can do, which is use a tool called a network sniffer. To study the dialogue. So this is where the sniffer is. You take a browser, you make it generate a request, send it to the server, it sends you back a response, and the sniffer, in the meantime, makes a copy of all the bytes that are sent and all the bytes that are received. So you can change a few things in the browser, then you can send the request, and then you can use the sniffer to see how the request was formed. And one of the nice things about HTTP is that all these headers have really meaningful names. It's not some byte, let's say, if it's 01, then it means accept language, and if it's 02, it means user agent. You actually have the user agent string written here in plain text, so you can read it with the naked eye without having to rely on some fancy instruments. So that's why this protocol is a nice learning tool. How does a download manager tell a web server to send it just a piece of a file instead of the whole file? What do you think? Well, besides you, maybe somebody else. I can hear the humming of the coolers. But can I get an answer to my question? All right, so Mr. Volunteer, please share the answer.
There is a special range header that we add to the request.
Mm-hmm.
And this way the server knows. We pass in the starting, I'm not sure. It's either the starting byte till the end byte that we are expecting from the server,
Mhm.
or it's two separate headers with the starting point and end point. It's either way.
Mhm.
Right.
So you're mostly right. So you can give it the range. I think the name of the header is accept dash range. And you say something like, let's say, byte 100 dash 500. And this means give me just the piece from this offset to that offset. So you can also say something like, give me the bytes from starting from 100 and until the end. You can also give it a range. You can also give it a set of ranges. This is useful in some cases, and in other cases this can be used as an attack against the web server. We might discuss it later, or you might do this as an extra bonus homework assignment to figure out how this could be really bad news for the web server. So, to give another answer to my previous question about resuming a broken download, you could either read that in the RFC, or you could use a download manager and then a sniffer and see what the download manager does when you resume a request, a download, when you resume a download. And then you compare that request header with the request header that was originally generated when you just began downloading the file. There will be just a few differences, and those differences will make it clear how a broken download is resumed. If you have no other questions, then our next point in the agenda is to hook up a computer to the screen and do this together. And then I will tell you about the actual assignment. Today's mini assignment is to be able to send a request to a server and get back a response using Telnet. So if Dima and I see you do that, the mini assignment is complete, and all you have to do is just go back home and implement the rest of the requirements. What are your questions for now?
What server?
Which server will we be using? Do we have internet access here? Well, then you can use any web server. Just type utm.md and that's it. If you have a local web server on your own machine, then that's fine. And if you don't, then just use whatever web server you find laying around and waiting for you. What are your other questions? Okay, if there are no questions, then I'm setting up my machine and we'll get started.